Hey, welcome back to your favorite technical mathematics course. We're going to look at basic algebraic expressions. There's our objectives. Let's recognize those first. So a little bit of vocabulary. An algebraic expression, just a combination of constants and variables, as you see down below with the example. The terms of the parts in an algebraic expression separated by a plus or minus. So like that's a term, that's a term, the y squared is a term, the xy is a term, minus 2y, that's a term. So how many terms does it have? There's 5 terms total. Now how many are like terms? So like terms have to have the same variables and the powers as well on those variables. So if you've got 3y squared minus 2xy plus y squared plus xy minus 2y. First thing we look for is we say, okay, let's look at this term, 3y squared. Is there any other terms with the exact same variable and the power? So it's got to be a y and it's got to be squared. And you say, well, there's one right there. So those two are like terms, 3y squared and y squared. And then you look at this negative 2xy. Is there any others that have an x to a 1 power and a y to the 1 power? And you say, you bet, there's the other one. Negative 2xy and xy are like terms. Now this one over here just has a y. That's it. So there's no other like terms with that one. So you just got the 3y squared with the y squared. The other like terms, negative 2xy with the xy. Now polynomials, so these are algebraic expressions. You get a single term and a sum of terms where you've got a constant variable with an exponent that's positive integers, the requirement on that, and the product of constants and variables with exponents. So all those down below here are polynomials. Okay, these are all examples of polynomials. And let me give you an example of something that's not, like 9x to the negative 1 is not. You gotta have positive integers up there. So in other words, a whole number power. Okay, here's another one. The square root, let's say 7 square root of x. That is not, because if you think about the square root of x, x to the 1/2 is the square root of x. So again, you've got to be a positive integer up there. Okay, so the 9x down here, that one's a polynomial. The 8x minus 2 right there, that's a polynomial. And negative 2x plus to the 4th plus 3x minus 4, again, all polynomials. Okay, so you can classify them 2 different ways. The first way we're going to classify them is by number of terms. Okay, so if you look at the 9x, that has 1 term, right? And so you call it a monomial, monomial, right? Whereas the second one, 8x minus 2, you got 2 terms. The 8x, you got the negative 2 there, 2 terms, so you call it binomial. If you got 3 terms, trinomial. Anything after that, if you've got like, 7x to the 5th minus 2x squared plus 4x minus 3, right? 1, 2, 3, 4. You just say, well, that's a polynomial with 4 terms. You kind of get lazy after the 3. But it has 4 terms there. So if you got 1, 2, or 3, they have specific names for it. A monomial, right? That's a polynomial with 1 term. Binomial, it's a polynomial with 2 terms, and so on. All right, the other way we can classify polynomials is by the degree. Okay, so if you look, here's your first one, polynomial 5. You notice there's no x there. Well, the x is missing. It's actually x to the 0, because anything to the 0 power is 1. Like 2 to the 0 is actually 1, right? So they don't write that. It's just 5, right? But the degree is 0. So if the degree is 0, you say, well, it's a polynomial of degree 0. But if it's a polynomial of degree 0, we give it a specific name. We call it a constant polynomial. The next one, 3x. Well, that's 3x to the 1 power. They don't show the 1 power up there. So that's a first degree polynomial, and we call that a linear. Right. The next one I'm looking for is you've got the 2x squared plus x minus 4. You take the term with the largest degree, so you take the second degree. It's a second degree polynomial. What do we call that? We call it a quadratic if it's a second degree. The third one, again, we take the largest degree. The largest degree is third degree. Both of those, if you notice, are like terms. They're third degrees. Third degree we specifically call cubic. It's cubic or third degree. Finally, the last one, we have a fourth degree. We call that a quartic or a fourth degree. Okay. Anything after that, you know, if it's a fifth degree, we just call it a fifth degree polynomial or a sixth degree polynomial. We don't give it a specific name, or at least you don't hear the specific names for that. And we've talked about some expressions that are not polynomials. You know, again, that would be like this, you know, not a polynomial. You've got a negative power up there, or like the square root of x, you know, that's not a polynomial. Right, because that's x to the 1/2 power, so on. All right, identify your like terms here. So you got 9a a term, 2b a term, 5b a term. Those two are your only like terms, the 2b and the 5b. The next one, do you have any other a's? Sure, the a and the 2a are like terms. Now, if you notice the ab, there's no other ab, so that's a loner. And you notice the negative 3b, there's no other just b's there, so it's only a and 2a. Next one here, you're looking at the 6r. There's no other just r's there. But look at this next one. You got negative br. There's another br. So those two are like terms. And then look at the r squared. R squared's all alone. There's no other r squares. This one down below, it's kind of in an interesting format. That's one term. That's two terms. That's three terms. That's four terms there. If you think about it in terms of, is there any other a minus b's? Well, there's another a minus b. If you're going to think about that prior to distribution. Okay. All right, down below, identify the degree. So we're classifying this by degree. Well, that's a second degree, so that's a quadratic. Now, this second one here is kind of interesting, the 2x squared y to the third. If you've got multiple variables, what you do is you actually add those up. So this is a fifth degree polynomial, which we did not mention this before. That's a fifth degree polynomial. The next one, 3xyz squared. That's a 2 of 1 power. They don't show the 1 power. That's a 1 power. So you just add them up. 1 plus 1 plus 2. This is a fourth degree, or a quartic, we call that, polynomial. Down below now, the 6x cubed, 2x squared minus 9. Again, you take the term with the largest degree. It's a third degree, x to the third. Down below, here's your three terms. Who's got the largest degree? This one down here. Add those up. That's a fourth degree. All right, let's change these to algebraic formulas. A first number x equals the square of a second number y. First number x equals square of the second number y. Second one, total surface area A of a cube equals 6 times the square of the length of one of its edges. So if you call, you know, you've got this surface area, right? If you call one of these lengths S, and you're finding surface area, that's like how much paint do you have, right? One of those sides would be S times S. So S squared, but there's 6 of them, right? 6 of those S squares. There's 6 of those faces if you were to count them all up. Bottom, back, and the left-hand side, you got all 6 there. Again, if you're adding them up. So the area A is 6 times the square of the length of one of its edges, which we're calling S. Okay. Identify the like terms here. You're looking at the A, there's no other just A's. You're looking at the 2AB, there's no other just AB's. And you're looking at the A over B. Again, no like terms on that. Second one, is there any other X plus Y terms? There's not. And then there's just an A term, it's just an X term. No other like terms. Is there any other X minus Y's? Well, there's another X minus Y. So those two are like terms on that. Now down below expresses fractions. So can you express this vertically? 2 divided by 5a. Can you express the horizontal division there? Can you express that vertically? Sure, you put the numerator on top. It's being divided by x plus 2 on the bottom. Evaluate the formula. So you're going to use p equals n times p minus c. You go ahead and plug in for the lowercase n equals 8, lowercase p get 250, minus the c, which is 140, and we go ahead and evaluate this. Make sure you do the parentheses first. 8 times 110, so we got 880 on that. Down below, we've got the Celsius formula here. P equals Celsius is 5/9 the difference between Fahrenheit and 32 degrees, and they're telling us plug the 68 in. If your Fahrenheit is 68 degrees, what's the Celsius end up being? So Celsius ends up the equivalent Celsius. So you go 68 minus the 32, so you get 36. Okay. And then you just, well, I can multiply that. So 5 times 36 divided by 9 will end up being 20. Or if you want to think about 36 divided by 9 right there. 5 times 4 is 20, all divided by 1. So 68 degrees Fahrenheit is the same as 20 degrees in Celsius. All right, well, thanks for watching, you guys. We'll see you soon.